Very nice. I was actually loaded up in Chrome for once, or Safari. So we have n being any value up to 10 to the gazillion. Find a positive integer m without leading zeros, divisible by 8. Formed by changing minimum number of digits in m. Okay, so we can do at most one change is necessary. If the length is 1, then we only have 8. Otherwise we need to take class 3, which would just be s 3 to the end. Again, if L mod 80 S times 10 Okay, this we have to be a little bit careful, because if we have zeros, then we could do some really screwy stuff can happen. Go up to the third last character plus ST. Yeah, seems legit. Okay, so we got an N-supported chandelier. Hive support holds up a weight WI. Okay, that's the initial weight. And then if we increase this weight to AI, then it will collapse. So X and Y is uniformly random non-negative integers. So X and Y there. So some random amount of weight goes to each one in an integer. Note that either one of the neighbors do not exist. All weight is added to remaining neighbor. If they don't exist, then okay, then the weight just does not occur. Minimum weight WI. Okay, so for each one we have to find the minimum weight, so that there's a chance that, so it's possible everything gets blown up. Okay, let's just remember we are doing minimum weight, not minimum guarantee. Sum of n over all test cases is at most 300,000, so you can take up to O log n or weight W. Both of those have a similar idea. So if we think about this here, okay, the corner cases are very easy. For those ones, you just bring it up to the minimum weight, and then you just transfer everything to the right. Assuming it's enough, then all of that weight's going to go over to the next one, and the next one, and the next one, and so on. Now, if we take anything in the middle, then we pretty much have to raise that singular weight to something high enough so that it passes our lowest and it passes our min required. Okay, so I'm thinking already of linear pre-processing, where we find, suppose the 7th case, how much does it take to complete the first one? Going from right to left, then the leftmost 2, then 3, and so on. And we do the same on the opposite direction. Then whenever we take a middle one, like 179 for instance, here we can just safely assume that given the weights here, that the next one just requires it to be up to 318. Then our limit is the 203 here, and then the sum of what is required to cause that chain reaction on the other two. So for the leftmost one, we'd need 276 added in. And for the right one, we need 49. If we only consider the requirement to break down here, we get 24. So it's either 24 or 276 plus 49. Wait, it's not 276 plus 49. It's 276 plus 49 minus our initial 179, because we can transfer all of that weight over as well. That would give 146. That's how we get the middle value. So we have to consider this somehow. So we'll do a left to right and right to left. Where the last value in left to right, since we're starting rightmost, is BR minus 1, AR minus 1. Right to left 0 equals okay, let's first solve right left. The absolute minimum requirements BRJ, ARJ. Then yeah, this is pretty much like asking how much of a chain reaction is needed. So with our last case, it would be 24 normally, but then we look at the next one. Well, actually, we'd still only need 24 for it to start from there, because then it pushes over to the next one. Like if we have enough for the next one, then it should be able to just keep pushing over. I think. Wait. Yeah, there's some sort of overflow we have to think about here, maybe. No, I don't think there's overflow because we get the 203 being pushed over there. Okay, so previous requisite is going to be J minus 1 plus whatever our required amount was there. Since AR's our starting amount and RL's how much we need to guarantee a chain completion. So that's the previous. So that means previous minus ARJ is another possible outcome. So thus RLJ equals maximum of MR and previous here. Or K in range. We have to okay, we already complete n minus 1, so n minus 2 to minus 1 with minus 1. Yeah, that should be the minimum amount we need to add on, right? So it does 276 first, then okay, I don't think 219 is correct though, is it? Yeah, I'm overestimating something here. MR is the minimum required. We set RL to be BRAR0. Yeah, so then we'd need 276. Takes our base value in there, so that should just be 398. 398 subtract our current value. Wait, that is correct. Then 219. 219 to cap 398. 8 and then push over to 122. You know what, this seems kind of legit. Well, we'll see how this goes. One, two, and minus one. Wait a second. No, that only eliminates the first one for sure. It just happens that everything else after that pushes in. Wait, then, yeah, no, something is definitely wrong here. Wait a second here. Because if our left to right calculation should not be 367, then it should be 276. Like 276 is correct there. Then after that, 219 I think is correct. 129. You're getting 398, I think. Like you pass 398 over as overflow. Yeah, you're definitely okay. That's definitely overkill. Okay, let me see. What's 276 to get to 398. Then this one is 122, 179. Yeah, even the second value now, there's no way that's correct. 398 minus 122 minus our base starting value. So like you have to, like it needed 276 more. So it's either that or it's okay, let's try something like this here. Okay, this is looking a lot more reasonable. LR answer 1 equals, or answer -1. Has to clear the two conditions. It has to clear there, and so you get 179 as a base start. So RL A minus 1 plus L to R A plus 1, subtract your current starting value. Nine 156 291. Think we might have got it. Okay, very nice. Okay, half an hour in, we're starting the next problem. We need XOR, and we can do a quick rank check here. Okay, we're looking like we're on very strong pace here. Yeah, we are definitely on a good pace. Okay, so we have a binary string, and we need to find two indices. Okay, wait a second here. So that I mod k is the same as j mod k. 2 times k is at most n. So what that means is that, yeah, the last character is always going to be able to be adjusted somehow. And then find the minimum operation count so that it's either all zeros or all ones. We know if we do the same operation twice, it's always going to lead to 0, 0. That's why this is always possible, and we can affect every single. If we set it up like this, then for every, we'll have a k different arrays of minimum length 2. And then for every single one, for each one, a single operation is just taking 2 adjacent values, replacing it with their XOR value. Okay, we have to be incredibly careful with. Do we? Wait. It's pretty much a if we can find. Okay, let me just see here. So the entire string must be converted to zeros. Okay, now what's the fastest way of doing this? One 0 to 1 change will occur at each operation. So then this should just be the number of 0. I think this is just a number of zeros. Okay, that's simple enough. Now with zeros, this is a little bit trickier. Because for removing ones, we want to initially target pairs. Or even better, if we can make pairs. Or actually, no, wait. Yeah, I think here is this. If we have it separated, we're going to just turn that into a 1 and then something like 101 is always going to take 4 operations, even though it looks completely inefficient to do so. Okay, let's give this a shot. I feel like there might be some inefficiency that I'm not considering correctly. So for j in range k, index is j, is this necessary? I don't know, but probably not. But I need my integers. answer 0 and answer 1 are both starting at 0. So if answer 0 or answer plus equals, what's a large enough value here? That should probably be big enough. Convert and you can also do a 1 count, so then we know how many 1s are remaining. If they are both 1, then our 1 count subtracts 2, our answer, plus we only need 1 operation to change those. And then we just push forwards 2. We keep going through this until we've either hit the last character or used the last 2. It will be 2 times our remaining 1s, since we're making the assumption that every single one requires 2 after that. Return answer. And then whatever's better between our 2 choices. Well, we did pass the sample input. It's not saying much, but who knows, maybe this is actually all there is to this problem. Okay, yeah, I am definitely misreading some. Well, not really misreading, but yeah, I don't think it's that simple. Yeah, there's too many people that solved this to actually be that easy. If it was that easy, this is the first problem, or second. Okay, well let's try a basic case. Okay, all 1s has been done correctly. Oh, wait a second. These don't have to be adjacent. So our one conversion is correct. That means, yeah, no, this is even simpler then. Yeah, never mind. I forgot how to read. Maybe. Oh, okay, there we go. That's pretty good. $49.07, and we begin the square problem. Okay, we're actually doing pretty well so far. So we have an array length and it's squarified if the product in any even length is a perfect square. And every odd length is not a perfect square. We have to find the longest subsequence that's squarified. So if it contains a square in a sequence, that's automatically not going to be squarified. So it's pretty much where okay, I'm already starting to see something here. If you have an array of 4 and you have a pair that's squarified, like the first 2 are squarified and the last 2 are squarified, then you have square times square, which is still a square. And square times not a square is not a square. Okay, we might actually be seeing a 4 problem solved today. That'll be exciting. So let's first read it here. It's a bit of a large array, but I mean, it should work here. Square root of 10 million is... Yeah, so we only run this 3,000 times. Okay, so we have to immediately disregard anything that is 2 times 2 times 2. Okay, wait, there's another thing we have to consider. It's a subsequence, not subsegment. That's one of the really big things we need to consider. So immediately what we can do is PR equals this. If squares j is equal to 0, so it's not a square, br dot j if n is less than or equal to 1, just return n. Okay, now we have to figure out the longest subsequence. What we do know is if we have a chain of A, B, C, D, if AB is square and CD is square, then ABCD is a square. And since all of these are not squares, if you take ABC, BCD, that sort of thing, those aren't squares. This is a Okay, that's another really weird thing. In the third test case, 8, 12, 12, 2, 2, 2. No, it's not even that. It's 27, 12, 12. So if we have something like 3, 12, 3, 12. We could take the 3 and we could take another 3, or we could take the 12. Pretty much we have to use a base value, and then everything from this base value has to not just be divisible by it, but like whatever its remainder is also still needs to be a square. That's the only way it works. We can use some divisibility rules. We can do it by divisibility to make it slightly faster. So in 27, 12, 12's case, our base value is 3. That is not a square, so it works. You have 27, 12, 12. Okay. if div I, then and we have to try the other one. I divided by div. So we try its alternate. Is this possible? Actually, wait a second. 500,000, 3,000, 500,000, 500 million. Shit. This is a 1.5 billion worst case, isn't it? We're doing n to the 1.5. I mean, if this is Meta Hacker Cup, this works, but yeah, I don't think many operations will fly. We need a better idea here. We're close, but actually, wait, is it 1.5 billion in the worst case? It's 1.5 billion if we keep running down every single time over and over and over. If we instead reference points, then it could be faster. Could it? Like, I'm not sure how you avoid. Not sure how you avoid some of the cases, since I mean, we probably... Okay, if it works for... Let's say if we had a very large number. If it works for like a lower I, will it work for I? Not necessarily, because... Yeah, we have to try both cases still. Okay, we're gonna finish up the solution, then try to do it with some minimalization techniques. Increase this by 1i. So x is our base, right? Yeah, x is our base, so x has to be 0. And the other one has to be if div times div equals I, then I is a square. So, okay, we don't even have to consider that case. Wait, where's my invalid syntax? Here. Wait, why is there invalid syntax here? What? d.getDiv is... Oh. Yeah, I'm pretty sure these are supposed to be none. Why did I make these 0? What the hell? Did I redefine D somewhere? Well, div and div is under I. Is div just... Am I not allowed to use div or something? What the... What the heck is going on here? Dictionary, give me the dictionary. Did I put an extra space or something? No, that doesn't do anything. Is it doing an invalid reference? That's the only thing I can think that's doing. What the... I mean, we can always do this as a just backup alternate. I mean, this does work. 2, 3, 0. The issue here is there's such an easy way to memory limit exceed. Okay, what's okay, TOE instead. That's another possible. the actual... What in the heck? Okay, screw this. Just try throwing this in, because like this is correct. Like there's no way this... If this is also given syntax error, something's gone very wrong. What the hell? Where is DI? What is this period doing here? What the heck? Was that there the entire Okay, well, resubmit. Did I type in Okay, now what happened? What in the... I mean, it's just throwing ChatGPT. Oh, crying out loud. Okay. Just want any sort of progress first. One, 2, 3, 29, 95, 29. Okay. Okay, we're gonna try the next part of... Wow, DI is at 1. Do I think this is the answer? Probably not, but it makes it faster, and at this point we're trying to cheese. Actually, wait a second. Stick it outside here in case they do some really scuff. So we go in full memoization. Okay, so yeah, there is something that's... Well, it passed the 4th test case. Something tells me I'm not supposed to be surprised that the last test case is probably like... Watch, it's probably like 10,999,999, and then 9,999,998, and so on. That's probably what the last of those 5 cases are, or something like that. I mean, calculating squares is okay. We figured we definitely have the correct idea. Our basing system is the issue here is that if you place 100,000, maybe, okay, wait a sec. Maybe you can just manually calculate the factors out. The problem is that there's 10 million. I mean, you don't have to go all the way. You only need to go to 3,000. Yeah, 163 mil. If we compare that to about, it's about 3,200. I mean, that cuts it in half. We have 86 million. That's about the number of factors we can expect. We divide those into each other. Then we're making 10 million lists, aren't we? I mean, we can try if it works. Wait, we can do better than this. Yeah, we can definitely do better than this. Okay, wait, I see what needs to be done. So we find the bases. If it's not in the base, skew. So it's not the base. Yeah, there's some really intriguing pre-processing challenges. And we can start at 1. just for completeness. If JJJ times we can use I as a base. I am so close. Still teal. Okay, yeah, I have to make the first part faster somehow. If this is 1 million, it's a lot easier, but this is 10 million lists. How do we make... That's the memory limit. Maximum source file size is 50,000 bits. 50,000 bytes. Like, the memory is fine, it's this computation is not occurring fast enough. Okay, I mean, this we don't need to initialize 10 million. Yeah, we only need to allocate the ones that we need to do. That should, yeah, that reduces, that's probably the dagger. So if it's divisible by the square, but it's not the square. And in theory, this should give the exact same result. 230. Okay, give this a shot. I think this will be the dagger. Still TOE. We're getting closer. We have to be getting closer. Yeah, our times are getting closer and closer here. Is this the dagger? It's queued, but we don't know what's going on with the submission. Okay, still. I swear we have to be close. This is just... We're just too close to the finish line. It has to be somewhere. That has to be alright, because we're only just taking squares and just throwing them in. Yeah, now we're trying to gimmick this. This is what happens when you have 5 test cases. Even if we have 500,000, no, we're going into the there's 3,000 possible. there. Yeah, we're still getting the 1.5 billion, aren't we? Yeah, there's one thing that I'm missing here, and I'm not sure what it is. It's actually pain since, like, I kind of know what. I have a feeling what is the problem, but I'm not sure if it's that. Yeah, the only thing can. The only other way is like. Oh no, do you need to. If you took all the factors, 3,000. Up to 3,000. Yeah, the 10 million list method might have been what I needed to do. I mean, I'm going to have to go to work first, so after I finish, then I can return here. If I have the idea, then then there's probably a follow-up to this for this question, since I'm really sure it has to be close.